Hi guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, Jest, TIFR, IIT-Jam exam, SET exam and other exams related to physical science. Okay, so this is the lecture number 7 of mathematical physics. We are studying Dirac delta function. So we are going to start. And before starting the class, I would like to thank you, the people who subscribed my channel, and also I would request the people who haven't subscribed my channel yet, please subscribe my channel. So I'm going to continue the class. Okay, so actually my class was ended automatically yesterday, and so and and I realized that after 15 minutes. Okay, so I'm going to continue the same class from where the class was ended. Okay, so we were studying the properties of Dirac delta properties. Okay, properties of Dirac delta function we were uh, studying. Okay, so 15th so 15 properties I have already explained. Okay, so now this is 16th property. When I was writing 16th property, that time class was ended automatically. Okay, so I'm going to start from 16th property of Dirac delta function. Okay, so this is the 16th property. Okay, just give me 1 minute, guys. There's some technical issue. Okay. There is some issue which I'm going to rectify. Okay, there is some issue, guys. Just give me. Okay, now it's working. Okay, so property number 16. This is divergence r cap upon r square. Okay, divergence of r cap upon r square, that is equal to 4 pi uh, del cube r. Okay, this is the 16th property. In last class we have seen we were not able to we have find divergence of r cap upon r square, and that was giving 0, and that was wrong, right? So for solving this vector, that is r cap upon r square, divergence of r cap upon r square, we use Dirac delta function, and using Dirac delta function, when we solve it, we get this value. Okay, this is 4 pi del cube r. Okay, so now the property number 17th. Okay, property number 17th is del square into 1 upon r square. This value is, just wait, this value is minus 4 pi del cube r. Okay, this is the this value, and I'll tell you how it happened. Okay, because if we find del into 1 upon r, okay, so it is going to be, this is 1 upon r, and this is going to be del upon del r. Okay, del upon del r into 1 upon r cap. Okay, so if we solve this, this is going to be minus r cap upon r square. Okay, so now if you find divergence of gradient of 1 upon r, this is going to be divergence of, this value is this, right? So this is going to be minus r cap upon r square, right? So that means this is, because this value we know, right, 4 pi del cube r divergence. This is minus will take common, so it is going to be same divergence of r cap upon r square, and this value is 4 pi del cube r. Very important property, guys, is 16 and 17. Okay, okay, so here now we'll solve this. The last time we have solved this one, right, this equation a dot ds, the where a is vector a is uh, r cap upon r square, right? So we found this is integration r cap upon r square dot ds. This I have done in last class, so that is 4 pi, we got this value. But when we are solving this one, divergence of r cap upon r square, that value was we are getting value 0, right? That was not correct. So here we'll solve this by using this property, right? By Dirac delta function, the Dirac delta property, we will be able to solve it. So this is not correct. Okay, so it is going to be divergence of r cap upon r square, and this is going to be which we know, that is 4 pi uh, del 4 pi del cube r, right? So now we'll find this one, integration, volume integration, divergence of r cap upon r square dv. This is going to be volume integration. This value is this by Dirac delta property. Okay, this one very important property, property number 16. We'll write here. So this is going to be 4 pi del cube r dv, and this is going to be 4 pi, and integration del cube r dv is 1. So this is going to be 4 pi. This is 4 pi. This is 4 pi. This verifies the divergence theorem, right? This is surface integration. Okay. So this verifies the divergence theorem. Okay. So this is the now property number 8. This is very important property. We will solve questions based on this property, and 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 then this property is very important, guys. Okay, and many questions have been asked which are related to this property in Jest, CSIR, NEET, GATE, and other physical other examinations related to physics. Okay, so this property is very important. This is del fx, so Dirac delta of fx, and this value is 1 upon this value is, so del of fx, del of any function. Okay, fx is any function of x. Okay, this is going to be sigma I 1 upon f dash xi mod, or mod f dash xi del x minus xi. Okay, this is very important property. Okay, So this is del fx. Del fx is sigma I 1 upon mod f dash xi del x minus xi. Okay, where xi is roots of the function, roots of the function. Okay, where xi is roots of the function, guys. Okay, just let me check. Okay, so and how we will find out roots? That will what we are going to do is for finding out roots, fxi equal to, we'll put fxi equal to 0 and we'll find the values of xi. Okay, so for finding the roots of function, what we are going to do is fxi equal to 0. If we put fxi equal to 0, this will give the roots of the function. Okay, I will solve questions using this property, then it will be more clearer to you. Okay, so okay, so now we'll solve some questions. Okay, before that we'll write here. Okay, since we know right here, I already explained yesterday, that is volume integration del cube vector r minus vector r dash dv. This is, if you this is the property, right? This is integration. Okay, guys, integration, volume integration. This is going to be volume integration del, this property I have explained. This is in Cartesian coordinate system. Okay, it's x minus x dash delta y minus y dash and delta z minus z dash dv. Okay, or dv we can write dxy, dx, dy and dz. Okay, dx, dy, dz, dx, dy, dz. Okay, this is the property. Okay, this one in Cartesian coordinate. Okay, Cartesian coordinate, and because this property I have already mentioned, this is del vector r minus r dash, this is, and this is del x minus x dash del y minus y dash and del z minus z dash. Okay, this property we know. And so similarly for this one, volume integration del cube r minus r dash dv is volume integration del x minus x dash del y minus y dash del z minus z dash then dx, dy, dz. Okay, so now we'll write del r minus r dash in terms of spherical in spherical coordinate system and cylindrical coordinate system. Okay, so first we'll write this in spherical coordinate system. Okay, spherical. Okay, so in spherical, del vector r minus r dash, this is going to be r minus r dash, this is going to be 1 upon r square del r minus r dash, okay, del cos theta minus cos theta dash, okay, and then del phi phi minus phi dash, phi minus phi dash, okay. This is phi minus phi dash. So this is the one. And in cylindrical coordinate system, cylindrical coordinate system, we can write del r vector minus r dash vector. This is going to be 1 upon rho del rho minus rho dash rho minus rho dash del phi minus phi dash and del z minus z dash, okay. So del r minus r dash in cylindrical coordinate, we'll write this is the del r minus r dash in cylindrical coordinate, and this is in spherical coordinate, okay. This is also important, guys. Okay, now we are going to solve question, because I have already mentioned in total 18 properties, okay, and including these, this is more than 18 properties, okay, of the Dirac delta function. Now we are going to solve questions based on the properties which I have already explained, okay. Just let me check. Okay, guys. Okay, so first question number first. These are very simple questions based on the formulas or properties which I have explained, okay. Question number 1, this is, you need to find out integration 0 to 3 x square del x minus 0 dx, okay. You need to find out the value of this, okay. So there's a property, right, which I have explained earlier in last class, that is this one, 0 to a fx del x minus a. It's this, let me check. This one, yeah, the limit is different. Limit is minus infinity to plus infinity, okay. Minus infinity to plus infinity. This is 0 to 3. Okay, this we know, right? This is fa. This is the property dx, okay. So minus infinity to plus infinity fx del x minus a dx, that is fa, okay. And a is a number that is between minus infinity to plus infinity. Then we use this formula, right? So here we are going to use the same formula. 0 is between 0 to 3, right? So we can write fa, that is x, and value is 0, right? It is going to be 0 whole square, and the value is 0, okay. The next question is question number 2. Very simple questions based on formulas, but very important to understand Dirac delta properties, okay. Second is 0 to 3 x square del x minus 1 dx, okay. this one we need to find out. So we can see 1 is between 0 to 3, right? So directly we can write this property, that is fa. So this is going to be x square. So instead of x square we'll write a 1 whole square. Okay, this is 1. Okay guys, using this property, very important property, minus infinity to plus infinity, fx del x minus a must be between minus infinity to between minus infinity to plus infinity. Okay, so this is going to be fa. So similarly here x, and we'll put 1, a is 1 here, so this is the function x square, 1 whole square equal to 1. Very simple. Next question, question number 3. Very simple questions based on the formulas or properties of the Dirac delta function, which I have already explained. Okay, next 0 to 3 x square del x minus 3 dx. Okay, this value is going to be 0 to 3. Limit is 0 to 3 and a is 3 here, right? Here, like a is 3. A is 3 here, which comes between this 0 to 1, 0 to 3, right? In this range. So it means this is going to be fa. Fa is x. X square means 3 square. Okay, this value is 9. I will keep on checking my YouTube as well, because in last class my class was disconnected automatically and I wasn't aware. I realized after 15 minutes of ending the class. Okay, so this is the one. This is the now question number 4. Very important property. Okay, this one. Question number 4 is 0 to 3 x square del x minus 4 dx. Okay, what will be the value? So here a is 4, right? And the limit is 0 to 3, and 4 doesn't come in between 0 to 3, right? This is out of the limit. This 4 is not between 0 to 3. Okay, out of 0 to 3 are the 4. So then in that case, if this one, right, this property, if limit is if the a is between limit, then this is going to be fa, else it is going to be, if it is not in limit, then it is going to be 0. Okay, so here it is going to be 0, because if, a, that is 4, is not between 0 to 3, then this value is going to be 0. This is the property of Dirac delta. Okay, next question number 5. Question number 5 is I think this is, let me just check. This is question number 1. This is question number 2. Okay, minus 2. Okay. Okay, now question number 5. This is this one is 0 to 3 x square x minus 2 dx. Okay, so this is also simple one. 2 is between 0 to 3, right? So in that case it is going to be 2 whole square, that is 4. Okay, now question number 6. Question number 6. This is 0 to 3 2x square minus 1 2x square minus 1 2x square minus 1 del x minus 2 dx. Okay, x minus 2 dx, this is the one. Okay, So now the function is fx is 2x square minus 1, okay, and here this a is 2, right, which comes between this one, right? So this is f is this 2, a is this 2 into 2 whole square minus 1, okay. So this is going to be 4, 2 into 4, 2 into 4 minus 1, that is equal to 7, okay. This is the one, so we are using this property only, okay. Next question, question number 7. These are formula based questions just to practice Dirac delta's properties, okay. I'm solving these questions for you. Next is 0 to 3, 2x square minus 1, this is the function, 2x square minus 1, 2x square minus 1, del 3x dx, okay. This we need to solve it. We'll use next page. So here the question is 0 to 3, 2x square minus 1, 0 to 3, 2x square minus 1, del 3x dx, right? So I have explained property number 2. So property number 2 is integration, or simple property number 2 is del kx, okay. The value of del kx is going to be 1 upon mod k del x, okay. This is second property of Dirac delta, okay. So del kx is going to be 1 upon mod k del x, right? We'll use this property here. So it is going to be 0 to 3, 2x square minus 1, okay, and this is going to be this 3 will come out, and this mod of 3 mod 3 del x dx, okay, using this property. So this is k is any number, okay. Okay, so now we'll take that implies 1 upon 3, mod 3 is 1 upon 3, right, and this is going to be 0 to 3, 2x square minus 1 delta x. Delta x we can write x minus 0, right, because I already mentioned this also. Delta x means delta x minus 0, simple, right? If we add or subtract 0, that doesn't change the value, right? So this one we can write like this. So 0 comes between 0 to 3, right? So this will write, that implies 1 upon 3 fa. F is this fa, so we'll write the value f into 0 square minus 1, and this is going to be, this is 0, 1 upon 3, 0 minus 1, and this is going to be minus 1 upon 3, okay, minus 1 upon 3. Very simple. So we have used second property, this one, and this is also the correct one, this, okay. So these are very important questions for practicing formulas, okay, practicing properties of Dirac delta function. Next question, this is question number 7, I believe, 6, 7, yeah. Question number 8. Okay, question number 8. Question number 8 is integration 0 to 3, integration 0 to 3, integration 0 to 3. This is 2x square minus 1, 2x square minus 1 delta 3x minus 2 dx, okay. This one we are going to solve, okay. So here this is the one, so we know the property, the second property which I already mentioned, that is this one, del kx, okay. I'm writing property again and again, so that you can easily learn these formulas quickly and memorize it. Okay, so this is going to be 1 upon mod k del x. Okay, this is the second property I'm writing here as well. So it is going, this is the function fx. Okay, so this is going to be integration 0 to 3 to x square minus 1, and this we can write like del. We can take 3 common and it is going to be x minus 2 by 3, right? For using this property we can write this like this. Okay, so now this goes 0 to 3 to x square minus 1, and this 3 will take outside like using this property, so it is going to be 1 upon 3 mod and del x minus 2 by 3. Okay, so now this is going to be 1 upon mod 3 is 3, 1 upon 3, and this is going to be 0 to 3 to x square minus 1, and this is delta x minus 2 by 3, right? So now the same 2 by 3 is between 0 to 3, right? So we can use that first property, this one. Okay, this one, right? Minus infinity plus infinity fx delta x minus dx is fa, right? This property. So this is going to be, so we'll write fa, right? 2 into 2 by 3 whole square minus 1, and we'll solve it, and this is going to be 2 to the 4, 4 to the 8, 3 3 9. Okay, this is going to be 4 by 9, and 1 upon 3 is always already there, right? So this is going to be 8 by 27 minus 1 by 3, and this value is going to be minus 1 upon 27. Okay, this is the answer. Very important question. Okay, for practicing properties of Dirac delta function. Okay, so this is question number 8. Question number 9, this one we are going to use. This is 0 to 3 x square plus 1. Okay, del x square minus 3x plus 2. Okay, dx. So we need to solve it. 0 to 3 x square plus 1 del x square minus 3x plus 2 dx. Okay, so we need to solve it. So it is going to be, so this is 0 to 3. Okay, function is x square plus 1. Will simplify this so that we can use Dirac delta property. So it is going to be, will solve this equation, and this equation is going to give value 3x square into 2x minus x plus 2 dx. Okay, we are solving this. That implies 0 to 3 x square plus 1 del, this is going to be, we'll take x minus 2 and x minus 1. Okay, after simplifying dx. Okay, so this value is going to be now we'll write in next page. So this is going to be, implies 0 to 3 0 to 3 0 to 3 x square plus 1. Okay, and this is del x minus 2 and x minus 1. Okay, this is the one. So here we know the property. Okay, this property I'm writing again. The property is del x minus a into x minus b. Okay, this property we know. This is going to be 1 upon b minus a mod, 1 upon b minus a mod del x minus a plus del x minus b. Okay, this one, this is important property. So this is in multiplication, right? Del x minus a, del x minus b. So how to uh, separate it? By this property. This is 1 upon b minus a mod into del x minus a plus del x minus b. Okay, you will use this property then. Okay, so this is going to be 0 to 3 x square plus 1. Okay, so this is going to be 1 upon minus 1. Okay, so minus 1 minus minus plus, okay, 2 mod. Okay, and this is going to be del x minus 2 plus del x minus 1. Okay, this is going to be minus 1, this is minus 1 plus 2 is 1, 1 mod is 1, so it is going to be 0 to 3 x square plus 1 del x minus 2 plus 0 to 3 x square plus 1 del x minus 1. Will multiply this with this and this. Okay, so these are two integration, and then we will use first property which I have explained, right? So this is, so see, 2 is between 0 to 2, 0 to 3, and 1 is also between 0 to 3. So this is going to be fa, means this is 2 square plus 1 plus this is going to be 1 square plus 1, right? And this value is going to be 2 to the 4 5, this is 5 plus this is 2, that is 7. This is the answer. So this property we have used, guys, very important one. Okay, practice questions to remember, so that these formulas will be in your fingertips. Okay, well, this is the one. Next question, this is question number 9. Okay, question number 10. Question number 10 we are going to solve. Okay, question number 10, and this is also very good question. So we need to find out integration, that is I equal to integration vector r minus vector a mod, very good question, del cube 5 r vector, okay, dv, 5 r vector dv. This we need to solve. Okay, this is volume integration. Okay, this we need to find, and where a is given, this is 3 I cap plus 4j cap. Okay, 4j cap. So this is given. Okay, we need to find this value. We'll use the property here as well. Okay, so this I is going to be integration, volume integration r vector minus a vector mod del cube 5 r vector dv, right? So what we are going to do, so this property, we'll use this property. This is del cube k r vector. Okay, this property is going to be 1 upon mod k cube mod del cube r vector. Okay, so taking this constant outside, we use this property. Okay, this one, if it is just del, then this is going to be del, these are property, del kr, this I have already mentioned, this is 1 upon k vector del r. Okay, this for x, right, which I have already mentioned. For if it's a del cube, so then is it going to be 1 upon k cube, 1 upon mod of k cube del cube r vector. Okay, we'll use this property here, so it is going to be 1 upon 5 cube 1 upon 5 cube mod. Okay, and this is going to be del cube r vector dv. Okay, so 1 upon 5 cube mod, it is going to be 125, right? So this is going to be I equal to 125 volume integration vector r a into del cube r vector, right? Or r vector we can write del cube r vector minus 0 dv, right? Adding 0 or subtracting 0 doesn't make any changes, right? This r cube, this we can, I'll write in next step, this will be more easy. Okay, this one is this r dv. Now we can write I equal to integration, volume integration, this is 1 upon 125 volume integration r minus vector r minus a del cube, this is r, right? R vector, so we can write r minus 0 vector r minus 0, that is not going to any change, that is not going to change anything. Okay, vector r minus 0. So now we'll use the property. Okay, so this is going to be okay, so this is the one, and this is guys mod square. Okay, this is mod square, this is mod square, this is mod square. Okay, this is mod square, and this is mod square. Okay, so this is going to be 100 1 upon 125. Okay, this is going to be so we'll solve this, right? This is going to be r, same the property we know, right? This is r minus, this is the function fx d cube r minus 0, right? So this is going to be 0 0, so this is going to be volume, I'll write first volume integration vector r minus a mod square. Okay, del cube r del cube r vector dv. Okay, no need to write 0 dv, right? And this value I have already wrote this property, this value is 1. Okay, sorry, this value is going to be 1, so this one r minus 0. Okay, you have to write it r minus 0. Okay, dv, so this is going to be vector r minus 0 dv. Okay, yeah, so this is going to be 1 upon 125. Okay, we'll reuse this formula, right? This is going to be fa, this is function, so r is 0, right? R is 0, so it is going to be 1 upon 125, and this is FA, right? So this is R. In place of R, we'll write 0. So 0 minus vector A mod square, right? And value of A we know here. This is given I cap, and also there is one more thing is given, that is the this is a sphere, okay, of radius. V is the volume of sphere of radius 6, okay. This is add in question. V volume of sphere, volume of sphere of radius 6 unit, okay. This is also given in the question, so we can use this 0 minus vector A mod square, mod A square, and this is going to be 1 upon 125, 1 upon 125. This is mod A square, and we know uh, A is given this, right? Since A is given 3 I cap plus 4 J cap, right? So the mod A is going to be root 9, 3 square plus 4 square 16, that is 5, root 25, that is 5. So it means mod A square is going to be 25, right? This we know. So we'll write here in place of mod A square, we'll write 25. Okay, we'll write 25. 25 will get cancelled. This one will get cancelled by this. This is going to be 1 upon 5. 1 upon 5 unit. This is the answer, guys. Okay. So very simple one. This formula you should know that fx. So this we know that is 0 to fa. That 0 to infinity fx into del x minus 0. We know if it is if it comes within limit, then it is fa, right? Similar we have used here. So this is the one. So we use two property here. Very good question actually. Here that is r del cube kr. Del cube kr, value of del cube kr is going to be kr. K is a constant, will take outside because it's del cube, so it is going to be mod k cube del cube r. Okay, this is the first property, and this is, and at last we use this property. Okay, this is going to be fa, and a is 0, right? So in place of r it is 0. So what this is the answer. I hope you understood it, guys. So these are the questions. Now we are going to solve a very important question, okay, and related to property number 18. I'll write this property number 18 again for you, but before that we'll write the question. Okay, question is question number, what is the question number? 9, 10, 11. Okay, question number 11. Question number 11. Question number 11. This is we have to find delta sin x. Okay, delta sin x we need to find. This is the question. So for property number 18, which I have already mentioned or explained, so that is what is this property? This is if del fx is function. Okay, del fx is going to be equal to sigma I 1 upon f dash xi mod del x minus xi. Xi is the root, xi are the roots of the equation, roots of the function. Okay, xi roots of the function, and which we can find out by putting fxi equal to 0. In function will replace x by xi. Okay, this is the very important property, guys. You will get questions in Jest, NET, GATE, and NT exam and other exams. Okay, this is very, so we need to find this value. Okay, guys. So we are going to solve it. Okay, so del sin x. Okay, del sin x is going to be, here we'll use this property, sigma I 1 upon f dash xi. The differentiation of sin x is going to be cos xi mod. Okay, we have used this formula, del x minus xi. Okay, so del sin x equal to sigma I 1 upon differentiation of sin is f dash x, that is cos xi. Okay, and mod, and then del x minus xi. Okay, we have used this property. Now will proceed further. So this is going to be del sin x equal to so before proceeding, so we'll find the roots. Okay, roots, how we are going to find? Function is sin x. Okay, sin x, function is sin x, so sin xi. So sin, for finding root, will write sin xi, will replace function with x, function in x with xi. Okay, so sin xi is going to be 0. It means sin, sin xi is going to be 0. We can write sin n pi, that implies value of xi is going to be n pi. Okay, where n is 0 plus minus 1 plus minus 2 plus minus 3 and so on. N is between minus infinity to plus infinity. Okay, so we'll put this value here. So it is going to be del sin x, it is going to be del sin x. Okay, this is going to be, like this one right here, sigma, where this is now n. Okay, sigma n 1 upon cos xi. Now in place of xi we'll write n pi. Okay, so cos n pi mod cos n pi mod yeah, and x minus n pi. Okay, in this expression, in place of xi we have written n pi, which is the roots. Okay, which are the roots. Okay, so this is the one, right? Now this is going to be del sin x is going to be, we'll solve it, right? So we're going to solve it. This is going to be this will write sigma minus infinity to plus infinity, value of n is this, so into 1 upon cos n pi mod x minus n pi. Okay, next page we'll write delta sin x. Okay, this value is going to be, so this is minus infinity to plus infinity, right? So we'll write this like, we'll take minus 2, so from minus infinity to plus infinity we'll take minus 2, so this is going to be sigma, we'll write like this is going to be 1 upon cos xi is going to be n pi, and n equal to minus 2. Okay, minus 2 pi, okay, mod minus 2 pi mod del x minus minus 2 pi. So this is n pi, right? So x minus n pi. So n pi, n is 2 minus 2 pi. 2 pi, okay, minus 2 pi, and this n plus 1 upon, will take minus 1, so cos minus pi, okay, n equal to 1 minus 1, okay, mod, this is going to be del x minus minus pi, okay, this plus will take n equal to 0, so it is going to be 1 upon cos 0 mod, okay, cos 0 mod del x minus n equal to 0, so del x, okay, and then 1, n equal to will take 1, this is going to be cos n pi means cos pi mod, okay, and del x minus n pi, x minus n equal to 1 pi, okay. Similarly, plus 1 upon n equal to 2 will take cos 2 pi, n pi equal to n equal to 2 pi mod, and this is going to be delta x minus 2 pi plus on infinity, okay. We have taken n equal to minus 2, minus 1, 0, 1, 2, okay, and so on, right? We'll simplify it. So this is going to be del sin x, this is going to be, okay, this is going to be, okay, so look at, so cos minus theta is cos theta, we know, right? I'll write cos minus theta is theta, cos theta, this is a property, okay, of cos, okay, cos theta, okay, and and cos 2 pi value is 1 and mod is 1, so it is going to give plus 1 value, right? 1 upon 1, 1, and this is going to be delta x plus 2 pi, okay. Similarly here cos minus pi is going to be cos pi value is minus 1, but there is a mod, so it is, this is going to be cos pi is, the value of cos pi is going to be 1, so this is delta x plus pi, okay. Similarly here cos 0 is 1, mod is 1, and this is del x, okay, plus similarly cos 2 pi 1 mod 1, so this is going to be del x minus pi for this one first, okay, cos pi minus 1 mod 1, because mod is there, so del x minus pi plus del x minus 2 pi, because cos 2 pi is 1 mod 1 plus so on, okay. This is the one, so this is the answer, guys, okay. So Dirac delta sin x, that is del sin x value is this minus, so we'll start with minus infinity, so it is going to be del x plus 2y, x plus 2 pi plus del x, x plus pi plus del x minus pi plus del x minus 2 pi, so on, okay. This is the answer. You can note down it as a formula as well, okay, for so that your question will become easy if we get such type of questions, okay. Well, very important question, guys. You can use, you can learn it as a formula also if you want it, okay. So it's very important, the value of del sin x, okay. Well, now we are going to solve question number 12. Question number 12, okay, very important question, guys, and this question is asked in Jest and NET both examination, okay. This is asked in CSIR NET and Jest, okay. So very important question. and we'll solve this problem using the property number 18, right? Okay, so question is, this is asked in NET and Jest both. Okay, so I'm writing the question first. So you need to find I equal to, that is integration 0 to infinity e to the power minus x del sin x dx. Okay, this question you need to find. Okay, this one. Options are given. Option number A, which is e to the power minus pi into e to the power minus pi minus 1. Option B is e to the power pi upon e to the power pi minus 1. Option C is e to the power pi, and option D is e to the power minus pi. Okay, this is, yeah, this is the question. Okay, so you need to integrate this value, and these are the options which are given. Okay, so we'll solve it. Okay, so this one, so we need to know the value of this, and we can easily solve it. Okay, so here I have already solved this, right? So the value of del sin x, I have already solved this one. So we'll directly use this formula now. This one I have already solved it, right? I have told how to solve it. So this formula we are going to use directly because we have already solved it. Okay. Okay. So we need to find out this integration. This integration is 0 to infinity e to the power minus x, this one. Okay, e to the power minus x del sin x dx. So this value of this will write here. So it is going to be 0 to infinite. This value is going to be, so we'll write directly, and or we can use property number 18 and reach here, this one, right? This, but we have already solved it, so I this doing same is, I don't think so it's good. So we'll directly use this formula because I have already solved what is the value of sin delta sin x. Okay, so same thing, we are going to write directly this formula. Okay, for sin delta, this is going to be e to the power minus x. Okay, e to the power minus x, and this value we know now. This is delta minus infinity to here, delta x plus 2 pi plus delta x plus pi, right, plus delta x plus delta x minus pi plus delta x plus 2 pi plus so on, right? This one. So this is going to be, and this is like dx. Okay, dx. Okay, we used this formula. Okay, this one, value of this is this, I've written directly here. So now this is going to be 0 to infinite e to the power minus x delta x plus 2 pi, okay, plus integration 0 to infinity, okay, this is the one, this is using like this, okay, plus 0 to infinity del x plus pi plus 0 to infinity del x, okay, plus del 0 to infinity this is e to the power minus x, e to the power minus x plus 0 to infinity e to the power minus x del x minus pi plus 0 to infinity e to the power minus x del x plus 2 pi plus so on, okay, this is the one. So here we can see I will use this property which this one integration minus infinity to plus infinity delta this one delta x, sorry, my apology, this is fx del x minus a, this is fa when a exists between minus infinity to plus infinity, right? If a doesn't exist between the limit, then this value is 0, right? So we'll use this formula here, okay. So here you can see this is e to the power x 0 to infinity x plus 2 pi, right? It means value of x the x is minus 2 pi, and minus 2 pi doesn't exist between 0 to infinity, so this value is going to be 0. Similarly x equal to the value of a is minus pi, right? And minus pi doesn't exist between 0 to infinity, so this is also this value is also going to be 0. But these values like this x 0, right? 0 exist and this exist, and we'll write this value, so this value, okay, so this is going to be equal to 0 plus 0. So these all values are these all values are going to be 0, because these are not going to exist between 0 to infinity, right? Because these values are minus values, plus this one, this is e to the power minus x del x minus 0, because this is del x x minus 0, 0 exists, so e to the power minus 0, this value is e to the power minus 0 is 1, plus here this one 0 to infinity x equal to pi, pi exists between this e to the power minus pi, okay. So this is going to be e to the power minus pi plus e to the power minus 2 pi plus so on, right? Because e to the power 2 pi exists this, and plus so on 2 pi exists between 0 to infinity, right? So this is these complete value are going to be 0, because these are negative values, and these values doesn't exist between 0 to infinity, right? Okay, so this is going to be then, that implies this value of I is going to be 1 plus e to the power minus pi plus e to the power minus 2 pi plus so on. So this is going to be series, right? Symmetrical series. So this is going to be I equal to 1 upon a minus r, 1 upon a 1 minus r, right? So this is 1 minus r is this one, this is e to the power minus pi, right? E to the power minus pi is there. So here we know, like this one, we know this is a formula. I would like to write it here. 1 plus x square plus x cube plus so on. If this is the one, this value is going to be 1 upon 1 minus x infinity, right? This is the formula we are going to use, okay. So this is going to be I equal to, so here the x is this e to the power minus pi. So it is going to be 1 upon 1 minus e to the power minus pi, or we can write 1 upon 1 minus e to the power minus pi. We can write 1 upon e to the power 5, right? 1 upon e to the power 5, and we'll solve it, and this is going to be e to the power pi upon e to the power minus pi minus 1. This is the answer, guys. Very important. Yeah, this is the answer. Very important question. So which option is matching? Let me check. E to the power pi and e to the power minus pi. Okay, just let me check. This one is e to the power minus pi, right? E to the power minus pi. This option B. Just let me check. This is 1 e to the power minus pi e to the power pi. Sorry, this is e to the power pi. Okay. So this is the answer, guys. Okay, so this is 1 upon e to the power pi, e to the power pi upon e to the power pi minus 1. So which option is matching? Option number B. Option number A, right? No. Just let me check. E to the power pi upon e to the power pi minus 1. This one, option number B is the correct one. Okay, so option number B is correct one. So this is the answer. We simplify it, right? E to the power pi upon it. This is the one. Okay, guys, so I'm going to stop here, and thank you so much for watching my lecture, and I would request the people who haven't subscribed my channel yet, please subscribe my channel and enjoy my classes which are free of charges, and my classes are absolutely going to help you to crack the exams related to physical science, all exams related to physical science. Okay, guys, so thank you so much. Bye now.